Hello everyone, my name is Caroline Milan and I'm a Master's student at the University of Plymouth. As part of my Master's project, I have been leading the investigation into the health of seagrass beds around the Channel Islands. This research was conducted as part of a wider project looking into the age and condition of seagrass beds on the associated blue carbon and species diversity. These results are available upon request. This presentation will focus on the preliminary findings of the seagrass health analysis, with more findings to come at a later date. Before I get into the presentation, I would like to say thank you to all the local partners involved, to Marine Resources at the Government of Jersey, to the Government of Guernsey, to the Alderney Wildlife Trust, to Guernsey Biological Record Centre, and to the Butterfield Group for sponsoring this research. So firstly, what is seagrass? Seagrass is the only flowering angiosperm to live underwater. It is an important ecosystem engineer, creating stable and structured habitat for many species while providing sediment stabilisation. The seagrass habitat is a hive of productivity through the delivery of fundamental ecological processes, including both nutrient cycling and carbon sequestration. There are over 30 seagrass beds across the Channel Islands made up of 2 different species. One species, a subtidal Zostera marina, and an intertidal species, Zostera knowltii. Seagrass is internationally important and has been identified as a high priority habitat under the OSPAR Convention due to high biodiversity and blue carbon value. Despite actions taken, seagrass beds are declining globally, being listed as a critically endangered EU red listed habitat and also are declining under OSPAR. Yet in local waters, they are actually expanding. For example, aerial images of Jersey have shown seagrass beds to be present for at least 25 years. However, in the last decade, there has been the establishment of new beds along the eastern coast of the island. Given that seagrass has a long lifespan and are susceptible to environmental changes, they hold the ability to act as biological indicators for their environment as they continually sample their surroundings. By looking at the nutrient levels inside of seagrass, we can get an idea of what is happening in the wider ecosystem. Stable isotope analysis of carbon, nitrogen, and phosphorus has been used as a way of measuring nutrient input sources. Variations can be indicative of elemental processing and also the surrounding water quality in the wider ecosystem. Bioindicator approach has previously been used to demonstrate the condition of seagrass beds in the British Isles. However, the Channel Islands were not included in this analysis. The use of a collective perspective can be beneficial to understanding the driving factors influencing seagrass health and also the long-term resilience of seagrass beds. To conduct this research, 23 Zostera marina and 11 Zostera knowltii beds were sampled through voluntary efforts from late May to late June of this year, following protocols adapted from Jones and Unsworth to 2016. The sample sites were selected in accordance with 2017 data to continue the research from 2017 and also allow for temporal comparisons across the locations. 10 plants were haphazardly extracted from each bed, with care being taken to preserve the roots to keep the blades intact. The longest blade of each plant was measured and all blades counted before the material was dried and crushed and transported for external CMP analysis. The preliminary research only uses the carbon nitrogen values, and additional phosphorus data will be available once analysed at a later date. In the wider project, the CN value was used as a proxy for condition, with previous research showing this value to actually depict the light availability to the seagrass plant. The seagrass was found to share a similar bed condition relative to their coastal location. Subtidal beds had significantly greater CN values than the intertidal beds in both Guernsey and Jersey East. The Zostera marina beds had CN values up to 49% greater than global averages in the Minkiers, Eckerhos, Jersey East and Guernsey, and these beds were deemed to be the best condition of all those we sampled. Approximately 70% of the Zostera marina beds sampled had CN values between 11 and 92% greater than the previous UK averages, making these beds the best conditioned beds in the British Isles. Across a temporal scale, the peat values in Zosto Marina differed across year and location, showing deterioration of some beds between 2017 and 2023. Location also significantly influenced the CN values in the Zoster and Ultii beds. However, caution should be taken when looking at the temporal comparisons, as a different laboratory facility was used in 2017. So instead, we will take location as the primary driving factor for the deterioration. So to put these findings into a wider context, with the preliminary CN research, we can see that seagrass beds in the Channel Islands are mostly in better health than beds in the rest of the British Isles. We can conclude that localised environmental characteristics drive the condition and therefore deterioration of the seagrass beds. Seagrass health is therefore susceptible to ongoing anthropogenic pressures, including both boat-based disturbances and eutrophication, that can reduce the light availability to the seagrass plant and therefore inhibit photosynthesis and prevent seagrass growth. Once the phosphorus data has been analysed, we can account for both internal nutrient balance and phosphorus load, which will then give a more rigorous health approximation of the seagrass. But as it currently stands, future management needs to address localised anthropogenic pressures affecting environmental conditions. Through minimising these impacts, we will be able to maintain the condition of and promote healthier and more durable seagrass beds, and maintain the high ecological status of these beds through the continuance of their provisioning services to the local communities in the Channel Islands and the wider ecosystem. Thank you for listening.
Can't hear you if you clap. Okay, healthy beds. It's pretty good stuff, isn't it? So I'm just going to run you through some of the other things that we've got going on across the Channel Islands, starting with Savvy Navy, which is an app which is designed for marine recreational users, and it's supposed to be sort of a one-stop shop for everything that you'd need to navigate safely, and that includes safe anchorages. So we've taken the mapped extents of all of the seagrass beds from around the Channel Islands and included them on the Savvy Navy app, and you can see it sort of here. And we're hoping that that will allow marine recreational users to make more informed decisions about where they choose to set their anchors. So it's an ongoing relationship with them, and as we continue to map our beds, we will continue importing them on an annual basis onto the app. So in the UK, another thing they do is point out the locations of advanced mooring systems. And, you know, I'm teaching grandma to suck eggs here, but you know, an advanced mooring system is just any system that holds the mooring chain suspended in the water column, so it stops that traditional mooring system scarring that you see. And there are examples of these already installed in the Channel Islands in Jersey, in St. Catherine's Bay, and we'll see a video of one of those a little bit later on. So supporting the health of our eelgrass beds is incredibly important, obviously, but to do this we need to understand some of the pressures that we're putting them under. And one of the ways that we're looking at doing this is with the landscape scale assessments of the bays in which we find eelgrass bed. And that might be looking at things like mooring systems, bait digging activities, and freshwater outlets. But in particular, recently, we've had a focus on the impacts of traditional mooring systems. So mooring impact assessments have been conducted in Guernsey in 3 locations. Fermain, outside the Kiwi Marina, and off the Rosaire Steps in Herm. And we surveyed 2 per site, following a methodology that's already been established in the UK. A team of volunteer divers went down and took 4 20-metre transects that followed the compass points using a 0.5 metre squared quadrat every 2 metres to capture the percentage cover of the eelgrass, the shoot density, and the blade length. And you can see sort of what that looks like here. So preliminary results from the Kiwi Marina can be seen on the graphs at the bottom there. But really, the main takeaways are that as there is a significant positive relationship between increasing distance from the centre of the mooring and increasing blade length. Another takeaway that we found was that there seems to be this decrease at the sort of 10 to 12 metre mark across all the variables that we measured. And we think this is probably from where there's been looping of the chain at low water causing scarification. We think that's probably linked with our 10 metre tides that we have around Guernsey. So similarly in Jersey, mooring impact assessments have been undertaken, except they focused on the informal communities, both inside and outside of mooring scarred areas within eelgrass beds. So sediment cores were taken and the number of individuals and the diversity of taxa were recorded, and it was found that there were significantly more of both of those variables outside of mooring impacted areas. Okay, so I think we're going to see the video from Jersey. It's of an advanced mooring system that they've installed. I believe it's a Seaflex. Yeah. And yeah, I don't know. Does it? Okay, I think that's me. Yeah.